Here in the given figure, a square OABC is inscribed in a quadrant OPBQ of a circle. If OA, which is the side of the square, is equals to 20 centimeters, then find the area of the shaded region. So here, a square is inscribed in a quadrant where the side of a square is OA, which is 20 centimeters. So its area would be 400 centimeter square. So in order to find the area of the shaded region, we need to subtract the area of square from the area of quadrant. And for to find the area of quadrant, here is a formula. With theta is the angle of the quadrant. Like theta is this angle. So for a quadrant, theta would be 90, and the area of a quadrant would be pi r square by 4. Now, in order to get the radius, which is OB, we can use Pythagoras theorem and OB a triangle to get OB, and then subtract the area of square from the quadrant in order to get the shaded region. Now let's see what the solution says. Like this, here in triangle OAB, by using Pythagoras theorem, we find OB as 20 root 2. This is 20 root 2. Then the area of quadrant OPBQ is pi upon 360 degrees into pi r square, which comes out to be 1 by 4 of pi r square, which is 628 centimeters square. And the area of square OABC is side square, and its side is 20 centimeters, so its area would be 400 centimeters square. Now the area of the shaded region is area of quadrant minus area of square, which is 628 minus 400 centimeters square, and it comes out to be 228 centimeters square. So this is our answer for the shaded region.